So, good morning, friends. The topic for today is the decomposition of a time series. So, I want to start the decomposition with example. Today is Sunday morning, and you may have tea with you. So, if I ask you that what are the different components of a tea, so you can say that tea is having milk, water, then the sugar, right, and the ginger if you have. So, these are the components of a tea. The problem is that we cannot decompose it. You cannot take the milk back from the tea. You cannot take the water back from the tea. So decomposition of a tea is difficult, but decomposition of a time series is very easy. The way we have the tea can be divided into its component: water, milk, sugar, tea leaves. Similarly, the time series can be decomposed into different components. There are four major components of a time series: the trend, the seasonality, the cyclical effects, and the irregular component. And today, uh, all of us, we will be clear about how to extract all of these components from the time series. So we have to extract these components. So the session agenda will be to discuss first what is trend component, what is seasonal component, cyclical component, irregular component, and we will understand all these things with the help of a live example, a views exercise. And after dividing the component, all series can be saved separately, and all series can be used separately. So this is a irregular component. The first chart is showing you the irregular component. The second chart is showing you the seasonality. The third chart is showing you the trend. And the fourth chart is showing you the actual series. So the actual series can be divided into different components. So first of all, let's start with the trend. What is a trend? Trend is the long-term movement, either upside or the downside. Like this. If you see this line, the line is moving up with time. So we can say it is an upward trend. All the stock prices, all the prices, right? All type of prices have the upward trend. Gold price, petrol price, share price, right? So they increases with time. Or in some cases, it may decreases with time. Some are having the decreasing trend also, like demand. It may be possible that demand of some product decreases with time. So what is a trend? Trend is a upward or downward movement. Now we divide the trend into three categories: linear, curvilinear, and exponential trend. So I divide the trend normally because after doing research, I found there are three types of trend. The first trend is a linear trend. The linear trend can be extracted with the help of this simple equation, where y is the dependent variable, y is the series, which you need to use for decomposition. Time is simply time variable, 1, 2, 3, 4, like this. And the power of time is 1. If you take only single time, this is linear trend. If you add time square, time cube, square root of time, different powers of time, that is known as curvilinear trend. So if you want to learn only linear trend, take only time. If you want to extract curvilinear trend, you have to take time and time square. The third kind of trend is the exponential trend. The exponential trend we can apply by using this equation. And to convert this equation into regression form, we have to take the log of both sides and do a small operation. So that operation I will show you how we can do that. Where time is the time variable. And when we run this equation, all the three equations when we run, we have to identify that which is the actual trend in the series, whether it is a linear trend, whether it is a curvilinear trend, or whether it is a exponential trend. So we have to identify that which kind of trend is there in the series. Suppose in an equation you found that the trend is curvilinear. So then we extract the curvilinear trend. If the trend is linear, although the linear trend is very difficult, but if it is found that the trend is linear, then we have to extract the linear trend and then exponential trend. Okay. So what is the detrending process? Now the detrending process means extracting the trend from the series is called detrending process. Now because it is a practical thing. So let me start with the example. So I am taking the data from this website. The reason of taking the data directly from the website is that you can see that how we can work on actual data set. So this is IIP data, and I'm taking from the Government of India website. So it is a authentic data. So there are different kind of series in this 1980-81 series, 93-94 series, 2004-5 series. Because IIP is having the different base year, so therefore there are different series we are having. Okay, so let's take this series, monthly time series, 2-digit level. I'm going to extract the monthly data. So when you click on it, the data will open here. This is the data set. And I'm going to extract this data set. So meanwhile, it is extracting. Okay, so data is already there. So I hope you can see the data set. So those who are from economics, they also like this. It's fine. So I open the data in the views. You can see. So we are having the IIP data. I hope I'm audible, visible.
Yes, sir. Yes, sir.
Okay. This is simple data. So if I click on IIP series and plot it, so I get this type of plot. This is the original series, actual series of IIP that we are using in the dataset. Now the question is that which type of trend we are observing? The trend seems to be linear, slightly curvilinear. So we have to identify first that which type of trend is there in the series. So there are 3 type of trends, and we have to check all type of trend and decide to take any one single trend. So it is clear that this series is moving upward. So the series is suffering from upward trend. So first of all, I am going to check the linear trend. So select IIP, then time, and open as the equation. So simple regression model. IIP is the dependent variable, time is my independent variable, C is constant. And you can check that the coefficient of time is significant. So linear trend is significant. In this series, there exists linear trend. And if you want to see the trend, just go to the prop, forecast. If you forecast, it will save a series. In the name of IIP, let me rename it IIP linear trend. So I'm saving the linear trend in the name of So you can see that this is a linear trend, and let's open separately. This is a linear trend, and plot it. So this is the linear trend that the series is having. So in this way, we can extract the linear trend. Now I want to check whether the trend is curvilinear or not. So this is my equation. And to examine the presence of curvilinear trend, I am adding the series time square. So I'm adding a new variable, square of time. So both are found to be significant. And previously R square was 97%, 92%. In this case, R square is 97%. So let me show you. If I remove, okay. So first freeze this. If I take only time, the R square is only 92%. Only 92%. So let's put it here. And now if I take time square, it is 97%. So we are having two trends here, linear trend and curvilinear trend, and it is 92%, it is 97%. So which is better? Curvilinear trend. Okay. So let's delete this table. Now we are having curvilinear better than the linear trend. If you want to see this curvilinear trend, just go to the proc, make forecast series, and let's rename it curvilinear trend. So now you can see that the curve is coming. And let's see clearly. If you click on this curvilinear trend in the data set, you are having a new variable here. And if we plot this graph, so this is curvilinear trend. And the question is that which trend is much better, linear trend or curvilinear trend? The answer is curvilinear trend. So we have curvilinear trend stronger than the linear trend. If you want to plot both, you can open these two series as a group and can plot it. So you can see that the two trends are here. One is linear trend and second is curvilinear trend. The third trend we are going to see is the exponential trend. Okay, now I delete all. So first of all, I want to show that what is actually the exponential trend. So let's move back to the PPT. In this case, you can see this equation yi equal to e to the power beta 0 plus beta 1 t1 et. So let me explain that what is the meaning of this equation. So let me write this equation here. So the equation was y equal to e to the power, let me write alpha plus beta into t into a. So first take the log of y, log of e to the power alpha plus beta into t into et. So you know that log a into log b is equal to log a plus log b. So we can write log e to the power alpha plus beta into t plus log et. And you know that log e is equal to 1. So alpha plus beta into time plus et, log e is also constant. So the equation of exponential time series is this. Actually, the equation of time series is this. And in this equation is known as log linear equation, because dependent variable we are taking log and independent variable is without log. So what happens in this equation, that this beta multiplied by 100 is equal to growth rate. And if you calculate the beta multiplied by 100 multiplied by 12, this will be equal to annual growth rate. Annual growth rate. So beta is always comes in the format of growth rate. This is the property of the log linear equation. So just look at this series. So we started with this series, taking the log of both sides, and log a into log b, log a plus log b. Log and e cancel each other. So this will be come here, alpha plus beta into time. Log error is constant, so we take constant. In this equation, beta multiplied by 100 will give you the growth rate, monthly growth rate. Again, if you multiply by 12, it will give you annual growth rate. So these things we have to check. Okay, so let's move to the series. So now this equation, we are going to run the exponential trend. And in this slide, I also represent exponential trend by this equation. So similarly, the exponential growth rate or exponential trend of a series can be estimated with the help of following model. So here we are taking the log of y, and time is the independent variable. So all these things is mentioned here. The slope coefficient beta of this regression model represents the value of the growth rate of the time series. If p-value of t statistic is less than 5% level of significance, it indicates that the growth rate is statistically significant. This model is known as semi-log model or log linear model. Now let's estimate it. So in eViews, I am going to run time IAP and time open as an equation, and I'm going to take the log of IAP. So taking log of the dependent variable with time C, now I'm going to run the growth rate. So R square is still 97, which is very high. So we can assume that this is also a significant. And you can see the beta of time is 0.0057. So what it means? This indicates that the growth rate of the monthly growth rate is equal to rate. It is actually a rate. So 0.0057 multiplied by 100. So it is 0.57% monthly. And if you multiply it by 100, it will give you okay. I hope you can see the screen now. Hello. Okay. Now tell me whether you are able to see the eView screen or not, because from my side it is visible. Yeah. Yeah. Okay. So let me run one more time. In this equation, I am taking the IIP and the time open as an equation, and I'm taking the log of IIP, and time is my independent variable, and click OK. So this is your equation, and how to understand it. So the beta of time is equal to 0.0057. From it, we can calculate the monthly growth rate is equal to 0.0057 multiplied by 100 equal to 0.57%. So it is almost half percent. And if you calculate by 12 annual growth rate, so 0.57 multiplied by 12, approximately 7%, I think it will come. So the IIP of India growing annually at a rate of 7%, and which is nothing, it is a GDP growth rate of the country. If you see the average growth rate, average GDP growth rate of the country is around 7%. But we are assuming the data of the time period. During that time period, the GDP growth rate of the country was 7%. So in this way, we can calculate the annual growth rate of any series. If you have any series like GDP or price series or sales data or demand data, so you can calculate the annual growth rate of that series by simply applying exponential trend equation. So, and in this equation, the R square is also found to be 97%, which is quite high. So we can also assume that this series is suffering from exponential growth rate. I have to check which is higher, because in curvilinear equation, it was also around 97, and in this equation, it is also around 97. So both are nearly same. Now, if you want to see the trend, so you can do one thing. You can just go to the proc, make a forecast, and the equation is exponential trend. And okay, so exponential trend is coming like this, and let me plot it. This is exponential trend graph, and you can see the exponential trend is coming like this. Now suppose I want to compare that how this exponential trend and curvilinear trend are different. So let's select both, open, and as a group, graph like this. So more or less they are coming same. Now I have to finalize that which trend I have to take for my decomposition. So this can be done by comparing the R square. Let me compare the R square of both. So here R square is 9713, and if I change the equation into curvilinear trend, now the R square is 9722. So I will select curvilinear trend for the decomposition. So I got the answer of my question, that which kind of trend is strong in this series. The answer is curvilinear trend. So which is my curvilinear trend is this. So this is the trend I already decomposed. Okay. Now if I remove or subtract this from original IIP, right? Let me write here. So now I have the trend. I have the original IIP. So what happens if I subtract trend from the IIP? So assume that it is a multiplicative, additive component. So I assume that they are additive component. So I have to subtract. If they are multiplicative component, I have to divide. So let's do first additive trend. So IIP minus trend is known as D trend. So we call D trend. So what is D trend? D trend is equal to IIP minus trend. So I'm going to run this equation and remove the trend from the IIP. So you can see this is a generate, click on generate, detrended. So I'm writing here detrended IIP. So after removing the trend, I left with three component, the seasonality, cyclical effect, and irregular component. This is called detrended IIP. So IIP minus IIP curvilinear trend. So I am removing the curvilinear trend from the IIP. So you can see that detrended IIP is there. So let's see how it looks like. Okay. So now this is the series. So IIP after removing the trend becomes this. So we remove the curvilinear trend and the series is looking like this. Now this series is consisting of three components: seasonality, cyclical effects, and irregular effects. So three components is still left in this series. Now the next step is to remove the seasonality. And let me show you one more thing. If I take IIP and let's take the plot of these two. So this is the original IIP series. Red is the original IIP series. And blue is the detrended, means after removing the trend, the series becomes this. So like you can plot the two different components, original and detrended. Okay. So we remove the trend from the series. Now we are moving to the removing the seasonality. So let's take the detrended IIP. Trend is not there. And I am taking the dummy equation. And those who attended the dummy variable, they know that how to use the dummy variables. So first of all, I'm running the equation number 1 without constant. And I have to check that in which month IIP was the highest or the lowest. So just you have to check the highest. So D3, you can see 22 is the highest. And D4 is the lowest. So either we have to remove D3 or D4. So any series you can remove, that is not a problem. So I found that in the month of March, the IIP is the highest always. In the month of March, the IIP is always higher. So I compare. Now I am going to run the equation after removing the March and adding the constant. So in this way we run the dummy regression model. Okay. So you can see that all our p value becomes significant. It means there is a significant seasonality in the equation. Okay. So seasonality is captured. If you want to see the seasonal graph, go to proc, make forecast, and so I'm just writing here seasonality. So I'm saving this forecasted series in the seasonality series, seasonality IIP. Okay, I'm saving the forecasted value in this. And let's see how it looks like. If I plot this graph, you can see the seasonal behavior of IIP. So these are the month where IIP was the lowest, moderate, and in this month the IIP is the highest. It is around 22. You can see that it is March. In the month of March, the IIP is always the highest. And why March? Because in March, most of the companies work hard to achieve the targets. So because every company want to achieve the target, so that's why they do very, very hard work in the month of March. So in March, we always have the highest IIP. And in other months, normally holiday months, the IIP is very low, like September, October, November. So these are holiday periods. So IIPs are always lowest. So seasonal behavior we can extract. This is the seasonal behavior of IIP. Similarly, if you are having the data of sales, you can find out that in which month the sales is highest, in which month the sales is lowest. If you have the stock market data, you can find out that in which day, on which day the volatility is the highest, on which day the volatility is lowest. So generalized behavior you can extract with the help of seasonality. Okay. Now this is detrended and this is seasonality. So what happens if I remove seasonality from the detrended? So symbolically, I am representing you. So first we have IIP. So we divided the IIP into trend and detrended. Now I'm dividing the detrended into seasonality, and the left will be cyclical plus irregular. So now I am going to do this step. Second, decomposition, removing the seasonality from detrended series. So how we can do it? Let's generate. Okay. So the new name of the series is cyclical and irregular. Equal to, so this component I want to draw, seasonality I already have, detrended IIP minus seasonality. So I am removing the seasonality from the detrended. Trend we already removed earlier. So what is left? Cyclical, irregular. So we have this series and let's plot it. In this series, only two components left. In this series, only two components left. One is cyclical effect and one is the irregular effect. So you can see that this is a cycle. If you can see the cycle like this, and in 2008 you can see the slump. In 2002 there is another slump. 1996 we are having a boom. So this is called recovery period. This is called boom period, and this is called depression period, recession, slump, recovery. So like this. So you can identify the cycle very easily from here. Okay. Now this series consisting of two component, irregular and cyclical. So how to remove these two? So we are having a function. Let's plot this. Go to proc, seasonal adjustment. You are having an option called Tremo seeds. Go to Tremo seeds, and we need only a regular component, irregular component, and we want to run at level. Just transform this level irregular, click OK, and you have a new series now. You can see that this is irregular, cyclical, irregular. So let me rename this series. This series is containing the irregular component. Irregular IIP. Okay, let's plot this irregular IIP. Okay, so this is the irregular component of IIP. And there are some, you can see this flash crashes, and this is because of subprime crisis. Because during that period, 2008 to 2009, the volatility was very highest, very high. So, but this is irregular. And now I want to extract the cyclical effect. So again, the method is very easy. Cyclical component of IIP equal to cyclical irregular minus irregular. Cyclical minus irregular. So we will have cyclical component, and if you want to plot cyclical component, make graph of it. So this is the cyclical component. So we have all the components. Cyclical component, in cyclical component, this is the variation in the series because of the month. So within the series, this is cyclical component, and we have all the components. So let me show you how this component look like. I take the picture of each component and plot here. So if you plot together, the plot will comes like this. This is trend. The trend we removed. This is the seasonality that we removed. This is the cyclical effect, and this is the irregular effect. So in this way, the series can be divided into 4 categories: the trend, cyclical, seasonal, and trend, like this. So it's, you can see that how easy it is to divide the series into different components. Now, because this part, up to this part, I show you how to do it manually. To understand manually is important because sometimes we need to do it manually. We have to remove the trend manually. We have to remove the seasonality manually by using dummy variable. We have other options also. So let me show you the other options. So first of all, I'm removing the all components. So I have saved so many components here. Let's remove. I hope you are having clarity on this. Okay. Even if I remove the dummies also, delete. Okay, so I do not need month also, month number also. Okay, so I have simple IIP. This is my original series. Now software is giving me some options which I can also explore. Go to proc, seasonal adjustment. So you can see that we are having, first of all, we are having Hodrick-Prescott filter. Let's go to Hodrick-Prescott filter. If you click on this Hodrick-Prescott filter, it will give you the trend series, trend HP trend 01. Click OK. So you can see that by directly this command, you can remove the trend. After removing the trend, the left over component is this. So just by one button, clicking one button, we can remove the non-linear trend from the series. And the green series is the left series. Okay, so let me do one more time. Click on the series is already come here, the trend. So let me remove this again. Click on IIP, proc. Suppose let me want to save this series. So I have to check whether this series is coming or not. Cycle, yeah. Plot it. So this is the leftover, means after removing the trend, the detrended series is coming like this. This is nothing, it is a detrended series. So we have removed the trend and detrended series. So if you plot both, let's plot both. So you can see the 3 series clearly. The green series is our original series, red is the trend, and this is the blue series is consisting of three component: seasonal, cyclical, and irregular. So this is the command called Hetrick Prosket filter. The only benefit of this command is that this command directly extract the non-linear trend very clearly from the series. This is represented by the red line here. Okay, let's see other commands. So I'm removing because in same name so many series will come. If you again go to IIP, now go to proc. So after looking at the Hetrick Prescott filter, now we are going to seasonal component. In seasonal component, we are having two important commands. One is census X12 and tremosheets. If I click on census X12 first, now this assumes that which kind of assumption you are considering, the series is multiplicative or additive. So multiplicative is only possible when all the values are positive and you don't know, not a single value is negative or zero. So then we can also apply multiplicative time series. Let's start with additive. Now, if I assume that the components are additive means the total component is equal to trend plus seasonality plus cyclical plus regular. So assuming the additive component, we can save all the components by clicking this. If you click on irregular, final irregular component, final trend cycle, final seasonally adjusted means after removing the seasonality, final seasonal factors, this I don't require. So I require trend, seasonality, and irregular component. So these series I want. Okay, and the base series is IIP. You just click, you will get the series in one command. Let's see one by one. This is the trend, and make the graph. This is called census X12 commands. So you can see that the command is successfully extracted the non-linear trend from the series. Okay. Then you can see the seasonal factors. Seasonal factors means seasonality. So seasonality, and this command is successful in identifying the increasing behavior of seasonality. So this is called non-linear seasonality. These are the much advanced components facilities provided by the EView software. Then you can also find out the irregular components. These are the irregular component extracted by the series. Irregular component are the pure random component. No information is available in this component. So if you want to model this irregular component, you can model it. So you can find out whether this irregularity is influenced by any exogenous series or not. So you can take some macroeconomic variables and can find out whether this irregular component are influenced by those series or not. Okay. Now, if you want to see the cyclical component, so we can calculate manually. Cyclical is equal to IIP minus IIP seasonal factor minus IIP trend minus irregular IIP irregular. So if I remove these three components from the IIP, I will got cyclical also. So let's plot cyclical component. Okay, not very clear. The cyclical component is not coming very clearly. Okay. We can try one more time by clicking the IIP proc X12. If I save this final seasonally adjusted series, So it is after removing the seasonality. So if you remove trend and irregular component from this series, you will get also cyclical effect. So we have seasonally adjusted series. Seasonally adjusted means removing the seasonal component. Yeah. So this removing the seasonal component, it is consisting of three component: trend, cyclical, and irregular. So from this series, if I remove the three component, so I will get the cyclical component. Let's try this also. So I want to calculate cyclical equal to. So there are different possibilities that we can do in EView. That all the possibilities I am going to show you. So IIP seasonal adjusted component, seasonality is already gone. So I just want to remove two components. One is the irregular IIP trend minus IIP irregular. So this command will also give me the cyclical effects. And let's see the graph. Okay, so the same series, but this is the cyclical effects, the leftover effects. Now I'm showing you one more command. Let's remove all these things because we have to save again and again. Now IIP, go to proc, seasonal adjustment. Now we are having the tremo seeds command, most effective command, tremo seeds. It is very good command. If you click on tremo seeds, so we are going to run on level IIP, and you can save irregular, cyclical, trend, seasonal factor, seasonally adjusted. So all these series we can calculate in one command, but the problem is that cyclical component is not calculated. If I run it, you can see the different, all these series are differently extracted. Let me show you this. The problem is that no command in EViews is giving you cyclical command directly. So cyclical series we have to calculate by removing the irregular from the other series. So all these series, like this is seasonally adjusted series, this is trend, this is irregular component, these are the seasonal factor, seasonal, it is seasonally adjusted, right? So all these series you can calculate by just one command. And if you want to see the graph, but the overlapping graph will come here, so it may not be very clear. So most of the series you can see here. It is always better to plot one by one, so that this is seasonally adjusted series. Let's show one by one. This is after removing the seasonality, and very clear picture. Then irregular component, this is trend, IIP trend. So let's see what kind of trend will come. So this is the trend captured by the tremo seeds command. Then seasonal factor means seasonality. And wait, I will see one more command after this. So this is the seasonal factors. So the problem that we run manually, we are getting the same seasonal factor, but in this case, the seasonality is also increasing, because with time the seasonality factor will also increases. So all these series we extracted successfully, and cyclical effects is not calculated, but it can be calculated by subtracting. Like, let me show you that. Suppose I want to calculate, this is CYC, this is the name of the variable, and how I can calculate seasonally adjusted. IIP seasonally adjusted means removing the seasonality minus, I have to remove two more, irregular and trend. So IIP removing the trend minus removing the irregular effects, and you will get the cyclical effects. And let's plot it. So these are the cyclical effects again coming in this way. So IIP don't have clear cyclical effects. Okay. Now, there are many options which we can use in EViews to extract these different components. This is EViews 8. And in EViews 10, we are having one more extra command, which is available only after EViews 10. Let me show you that. If I run EViews 10, why I am showing you EViews 10? Because I have one more benefit here. Okay, so this is my data. And click on IIP. Okay, so if you go to proc, seasonal adjustment, so you can see that I am having one more option here that is called STL decomposition. So STL decomposition is the new option that I have only in EViews 10 plus version. So if you click on STL decomposition, so the software is assuming monthly series. Software is giving you seasonal adjustment factor, trend, seasonal adjustment, seasonal factor, seasonal adjustment, and all these series comes in one graph. So this is the original series. Let's take, this is the trend, this is the seasonal effects, and this is the now I think you can see better. So you can see that this is the original series, this is the trend series, this is seasonal series, this is a remainder, and this is seasonally adjusted. So a remainder means this series is consisting of two components, cyclical effects and irregular components. So you can save all these series in one command, and doing decomposition in EViews is very easy now. So you have the seasonally adjusted series, seasonal series, and all these series automatically calculated in one command. So in total, we are having commands like, okay, first of all, IIP, click on IIP, go to proc. So Hodrick Prescott filter is one command which we are having, only removing the trend. Then we have census X12 command, Tremoseed command, and STL decomposition. So all the three are substitute to each other and just giving you different outputs so that you can analyze all the component of a series. And one more thing I'm going to show you. Suppose I assume that the series are multiplicative. Assuming that they are multiplicative, because in previous command I was assuming that the components are additive. Now let's see if they are multiplicative, how they looks like. So assuming that they are multiplicative components, multiplicative means the total IIP is equal to trend multiplied by seasonal multiplied by cyclical multiplied by irregular. So assuming the multiplicative behavior, you can also calculate it. Seasonal factors, trend, irregular component. So I'm calculating only three. And cyclical component I can calculate by using this series, 4 series. So if they are multiplicative, then how they look like? So first of all, let's see the trend. Okay, I think there are multiple series. I have to delete all first. Otherwise, they will create confusion. Yeah. So just one more time. Go to proc, seasonal adjustments X12, assuming multiplicative, all the series. Yes. Now click on. So you have irregular, seasonal adjusted, seasonal factor. Let's see seasonal. So assuming that the series are multiplicative, the seasonal effect is coming like this. So slightly different graph. So with the assumption of multiplicative series, you can also decompose like this. Now, how the trend look like? The trend is almost similar, and this is irregular components. Irregular components, and the only component which is left is cyclical, and we can calculate it from here. Cyclical equal to IIP minus IIP trend. So first of all, I am removing the trend minus IIP seasonal factors, and minus IIP irregular. But I am doing one mistake that it is multiplicative, so I have to divide it by all. Because it is a multiplicative, so minus will not work. I have to divide by all the series. And taking the, so in this way we can calculate the cyclical effect in multiplicative series. And let me check what kind of graph I'm okay. So same graph, cyclical graph is coming almost similar in all these series. Okay. The concept which we have understood is that in first case we assume that IIP is equal to trend plus seasonality plus cyclical plus irregular. In second case, we assume that trend IIP is equal to trend multiplied by seasonality multiplied by cyclicality multiplied by irregular effect. So this is called additive components, and this is called multiplicative components. So we can decompose any series in all the component very easily by doing few commands. And after doing this, you can check one more thing. IIP, if you check the unit root. So I am showing you that it is non-stationary. It is non-stationary. So sometimes just after removing the trend or just after removing the seasonality, it becomes stationary. So this is our seasonality adjusted series. And if you check the unit root, so still it is non-stationary. So in this case, removing the seasonality is not useful to make it stationary. So, but I have seen in many series, after removing the seasonality, sometimes the series becomes stationary. So this is another benefit of this. And if I take the d log of this series, let's say by differencing, so you can see that by simple differencing, it is also non-stationary. So simple differencing is not also working in those series which are highly seasonalized. So seasonality always also helps you in making the series stationary. And after removing the component, now the question is that what to do? After removing the components, what to do? So the benefits of the decomposition is forecasting. So if you want to forecast a series, you can do the trend forecasting, you can do the seasonal forecasting, you can do the cyclical forecasting, right? Those in economics, the people are interested in identifying that whether the series is in which phase, whether it is in recovery phase, whether it is boom phase. So you can plot cyclical effects very clearly and find out that in which phase we are in. So this is another benefit. For forecasting, trend forecasting is very, very common in most of the economic time series. Suppose you want to know that what is the value, what will be the value of revenue after 5 years. So just analyzing the trend, you can do the trend forecasting. So similarly, you can do the growth forecasting. So forecasting of the series becomes very easy after removing the different components. So you have heard the word that trend forecasted series, growth forecasted series, then seasonal forecasted series. So on the basis of this decomposed components, you can do the separate forecasting. or you can also use the different component in different models. Suppose you are going to apply VAR model, ARDL model. So rather than taking the IIP component, you can take the different components. So this is another advantage. And if you want to apply GARCH model or any other model, so you rather than taking the whole series, you can take the component wise analysis. How the seasonal behavior influencing the volatility, how the irregular component improving have an impact on the volatility. So you can use the different components in different situations. So that's it for today. And I hope today the purpose is that how to decompose a series, any time series. In marketing, it is very useful because we have to decompose the sales series, demand series. We want to know that when the demand is high, when the demand is low, at what rate demand is increasing, what is the trend in the demand, what is the irregular component of the demand or sales. In economics, we use different series like GDP, IIP, WPI. So different series are having different components. Like IIP is one of the example. So in this way, you can decompose the component and use the different component for different purpose. So